Hi, this is going to be a very quick walkthrough of a MRP ring and subring configuration. The design of this is going to be very similar to what I'm showing here. So what we have is we have a Greyhound rack mount switch and two of our RSP switches. These RSP switches, because we're going to create this subring, have to be at least the 2A, if not the layer 3 variant. So Greyhound, two RSPs. The Greyhound is going to act as the redundancy manager, so the redundancy manager is going to be enabled in this switch. And on all of the other switches, the redundancy manager will be off. The ports that we've standardized on for this network is the ports 1 and 2 for this MRP base ring. Then there are some additional MRP devices. In this case, these are talking Profinet MRP. They will be individually configured by the vendor. So what we're going to do here is we're going to walk through the commissioning of this Greyhound as well as these two RSP switches. We're going to set this MRP base ring as VLAN 2. You'll see it in the settings. And then what we're going to have is we're going to set this MRP subring as VLAN 0. Because we're defining the ports on these switches, what we're going to be able to do is we're going to be able to have all of the individual subrings as VLAN 0. So if there's a subsequent ring, that subsequent, or should I say subsequent subring, that subsequent subring would then be terminated, say, on port 10 on this RSP and on port 10 on this RSP, and that too would then be able to have the same VLAN 0 designation. So that said, what we're going to do is we're going to start off with the IP addressing. So we have the Greyhound as a 10.10.10.2 on a 24-bit subnet mask. Oops, may as well correct this real quick. A 10.10.10.3.24, and then a 10.10.10.4 24-bit subnet mask. So we're going to start with an application called HighView. HighView is our switch discovery tool as well as switch management tool. And what we're going to do is we're going to, we've already gone ahead and we've scanned the network, obviously making sure that the LAN card is connected. I've given my LAN card a static IP address of 10.10.10.99 on a 24-bit subnet mask. So if I do a rescan of the network, you'll notice that the switches don't have an IP address. The switches from the factory do not have an IP address. What this allows me to do is it allows me to double click on this, and or what I can even do is I can signal that switch just to visually identify the switch, and I've clicked on this and all of the LEDs on this switch are flashing back and forth. So it gives me a very quick way to visually confirm the switch that I'm currently dealing with. So I'm going to double click on this, put this onto 10.10.10.2, I believe it was, 255.255.255.0, don't need a gateway, and we'll call this the Greyhound A. Okay, and you'll notice that this is now called the 10.10.10.2 24-bit subnet mask Greyhound A. You'll also see here this is the software rev. Because the subrings are going to emanate from these RSPs, again, as long as it's a 2A or a 3S, it will do this subring thing. So this guy here, we're going to make a 10.10.10.3 on a 24-bit subnet mask, and we're going to call him RSP A. And one thing that I didn't point out in the previous time that I set the IP address is it will set the IP address, but it does not physically save it to the non-volatile memory. So any changes that are made in the switches are done in a volatile memory, meaning that if I power cycle the switch, those changes will then revert. And we're going to take care of saving that as we go into the switch management. RSP RSP-B. Interesting. It will not let me put an RSP-B in here, but it let me put an RSP-A in here, so we're going to call this RSP-B. Let's see if it'll take that. It won't take the dash on this one. Okay, underscore B. Did I make a mistake somewhere? Did I put a comma somewhere? Okay, let's redo this. 10.10.10.4 255.255.255.0. Ah, okay. I must have fat-fingered something. Okay, so we have an RSP-A, we have an RSP-B, we have the Greyhound addressed on it, 10.10.10.2, 3, and 4, all on its 24-bit subnet mask. And I'm now going to right-click on these, and I'm just going to do a quick ping just to make sure that I actually can reach the switches, so the device is reachable. So if I can ping it, I should also then be able to talk to it. And what we're now going to do is we're going to go into the GUI on that switch. And this is just the fingerprint. You can either click yes or no. There's really no real best practice. Seeing that this is a switch that I'm going to be dealing with on a very regular basis, I will do a yes. And I'm now going to go in as the admin with the admin default password, which is private. And the private is in all lowercase. And you'll see that this Greyhound here is actually one of our older firmwares. So what I'm going to do is I'm going to do a quick update of the firmware so that it is a more representative depiction of what you will see when buying a new Greyhound, which is currently shipping with our HTML OS. So I'm going to pause this. I'm going to update the switch. So if you need to see how to update the switch, you click on Software, and from Software you would then browse to the file. So I'm going to go grab the file real quick, and I will be right back. So what I've done is I've downloaded the firmware, and I've extracted the respective bin file, and it would be the Greyhound's GRS. Where is it? I don't see it. And admittedly, it would help if I actually had copied the right file. So here's that file. I'm going to click open. So you'll see that it's currently set in here. It's ready to go. So what I'm going to do is I'm going to hit update. This will take about 4 minutes or so, and it's now pushing the firmware up to the switch. Once it's done, it'll give you a notification. It'll also show when you do the reload afterwards that the stored version is the firmware that I just pushed up to that switch. So I will pause this and we'll resume once it's done. So we see that we now have successfully loaded the firmware into the device. We will now do a reload, and when we do a reload we'll see the updated firmware in stored. Now one of the things that we need to do in order to activate the firmware is actually reboot the switch, and during the reboot it is going to then load this new config. So they're unsaved config changes. Yes, we do want to save them because the IP address is also one of them. So what we're going to do is we're going to go ahead and do this this update. Okay, configuration saved. We're going to do a cold start. This is going to allow us to reboot the switch across the network or over the network. And I can also tell from the firmware on these, this is 7.0, so everything after 7.0 will have the new HTML5 interface. So the Greyhound here had firmware Rev 6, and once that Greyhound comes back online, we are going to, or should then see, this be a 7. So the switch is finished booting or rebooting, and what we're going to do is we're going to do a quick refresh here just to show what I've been talking about as far as the firmware rev. And here we have the Greyhound. You'll now notice that this is on firmware rev 7. I'm going to do a right click, go to GUI. And you'll also notice that it's now pulling up an HTML page. This is HTML5. So it's a much different look. We're going to log in with admin and private again. Again, private is in all lowercase, as is admin. And here we have the switch status. We have a few alarms. We're not going to get into the alarms in this video segment, or any of the monitoring of the switch. We're going to focus on configuring the switch. So one of the first things I'm going to do is I am going to go to switching, under layer 2 redundancy for MRP. And again, this switch is going to have MRP enabled. We're going to connect ports 1 and 2, and this is going to have the ring manager enabled. And I'm going to hit set. And the other thing that this is going to have is that for spanning tree under port, we're going to turn off spanning tree on ports 1 and 2. So I currently don't have the network configured as a ring. Instead, it's a linear topology. So I have one of the ring segments purposely broken. And so I've disabled spanning tree and on those ring ports on ports 1 and 2. So ports 1 and 2 for MRP. And then for spanning tree on the port, I've turned it off on ports 1 and 2. So this is for this Greyhound switch right here. The other thing that I'm also going to do is I'm also going to set MRP to VLAN 2. So going back to MRP, VLAN ID, we're going to make this VLAN ID 2. Okay, so this is everything that we need to do here. We're going to go ahead and save this configuration, and we're going to save it. Okay, configuration saved. You'll notice the floppy disk is no longer flashing up here, which means that there's nothing left to save from the volatile memory. We're now going to go back into here, and we're going to grab this guy, and we're going to go into the GUI as well. And this one already has the HTML5 OS in it, so admin private. And here too, we're going to go down to switching. We're going to go to layer 2 redundancy. For MRP, we're going to enable it, hit set. here, it's going to also be ports 1 and 2. We're not going to have the ring manager enabled. There's only one ring manager allowed in a MRP ring, and this is being held by the Greyhound. And this is also going to be on VLAN ID 2. And the other thing that we're going to do is we're going to go into FuseNet and we're going to enable a subring. And we're going to enable this as well. And we're going to create an entry. And we're going to call this subring. Instead of A, we'll call it subring 1. We're going to make this active. And we're then going to define the port, and the port on this is we have ports 5, 7, 9, and 11 that in this switch are SFP sockets. So what I've opted to do is I'm going to select the last port on this switch, and this one is going to be a subring manager. The other one is then going to be the redundant manager. So this one's going to be subring manager. We're going to leave him on VLAN 0. So we're going to hit OK. And then we're going to go to spanning tree, to port. And on port, we're going to disable it on the MRP, the base ring, and also on our subring port. So I'll just do a quick visual. VLAN ID 2, it's on, ports 1 and 2. Okay, we've got a flashing disk. We're going to go ahead and click on that, and then we're going to go save. And this now just leaves us with one more switch to take care of. And that is this switch right here. And we're going to go admin, private, and we're going to go to switching. Under switching, layer 2 redundancy, go to MRP, and we're going to enable this. That's going to be ports 1 and 2. The ring manager again is off. It's being done by the facilitated by the Greyhound. VLAN ID 2. Enable that. Hit set. Then we're going to go to FuseNet subring. And this is the other switch in the subring. So we're going to enable this. And we're then going to create a new entry. And this too is subring 1. And the name is just it can be anything. It's not driven, it's not tied in any form or fashion. This is user definable. And in this case, on this switch, just for consistency's sake, we're also going to select port 11. And this is going to be the redundant manager, not just the manager. So the previous one was the manager, this is the redundant manager. We're going to leave it at VLAN 0. We're going to hit OK, give it a set. And the last thing that we're going to do is go spanning tree port. Under port, we're going to disable ports 1, 2 for the MRP base ring. And then to go down into the subring, we're going to disable it on port 11. So we're going to hit set. And so what we've done here is we've configured this as the redundancy manager for ports 1 and 2. For this RSP, we've enabled the MRP on ports 1 and 2, this subring on port 11, and we've replicated this on this same switch. So with that, we're going to give this a test here in a second, and we'll see how everything goes. Okay, so we're going to do one last thing here. We're going to verify the the settings and everything before we plug everything in. So we've got our RSPB, and the RSPB for MRP. It's currently enabled, ring manager off, VLAN 2, ports 1 and 2, and this should also be on for MRP, so on ports 1 and 2, ring manager off, VLAN 2, and this should have, whoops, admin private. This should have the redundancy manager on, and otherwise all of the same settings. It's on, VLAN 2, redundancy manager on, which is good. Okay, so what we're going to do is we're going to close the ring, and I just closed it, and the amber LED for the switch has for the redundancy manager on the Greyhound has gone from amber to green, so the redundancy manager is currently active. And if I do a refresh here, it also says redundancy available. So you'll notice that it's currently forwarding on this port, it's being blocked on this port. If I do a refresh on here, it says redundancy available. They're both forwarding, and we should have the same on this switch, redundancy available, and both are forwarding. Okay, so our base ring is done and it works. The next thing we're going to do is we're going to go to FuseNet and just verify the settings for the subring, and subring is subring -1. The name has no bearing. One could be called hippopotamus, the other one could be groundhog. And operations on, subring -1, port 11. This is the redundant manager, so the other one needs to be the manager. Port 11, I've renamed this one subring -1 just to make sure that we're consistent, and they're all on VLAN 0, so they're good too. So theoretically, all we now need to do is just plug in the other networks. So you can see here, if I do a refresh, this one's not connected, and on this port, if I do a refresh, it's currently not connected. So I'm going to plug this into one of the switches, and then do a quick refresh just to show. So this one's now forwarding, and I'm going to now plug in the other one. And if I now do a refresh on this, this one is now blocked because we now have a ring. And if I do a refresh on him, he is now forwarding. So we have our ring built, or our sub-ring built, and one is forwarding, the other one is blocking. And if I unplug one of them, so I want to unplug the one that's forwarding, that's on .3. Let me do a quick find. So I want to unplug this guy. So I've just unplugged him, and we're going to do a refresh. He's now not connected. And if I do a refresh on him, he is now forwarding. So what I can also do is I can also do a quick ping just to have an additional visual. And we're going to ping 10.10.10.12. This is one of the devices on the other end. And I'm going to get another ping going. So there are two devices that are in the MRP subring, so 10.10.10.13, I believe it is. There's one of them, and here's the other. So what I'm going to do is I'm going to break one leg of the subring. That would be this guy. So I've just broken one of them. You could see a slightly extended round trip time of 13 milliseconds on one of them. I'm going to plug him back in, and I will now unplug the other. So I've unplugged the other, and as you can see, packets are still flowing. I will now unplug both just to prove that there's no hocus pocus going on this end. So you'll see that there's now a timeout with both ends unplugged. Plug in one and plug in the other. So, hope this was informative for everyone. Last thing I'm going to do is go through all the switches, make sure that we do a save, just in case there is a power break or a power reset. This way it'll hold the configuration in the non-volatile memory. This one doesn't have anything that's been changed, as nor does this one. So, we're all good. Hope this has been informative. Have a great day.